Thank you, Professor. Dear colleagues and professors, let me introduce myself. My name is Vladimir Černicin, from the Faculty of Mechanical Engineering, University of Belgrade, and I will present you my master thesis, Energy Analysis of Safe House Building and Energy Improvement by Heat Pump Implementation. Lots of colleagues before me talked about energy efficiency, so I will not that much. Energy consumption in buildings are about 40% of total energy consumption, and increases every day. So European Union and communities bring directives and regulation to decrease that number. One of directive is APBD, Energy Performance of Building Directive, famous rule 2020-20, and obligation of Serbia is to sign some of this directive and fulfill till some year. In this project, we've taken a real object, a safe house building. Safe house is a building for protection of women and children from violence, and there had much problems with the bills for electricity and thermal comfort. They have installed electric heaters in their building, so it was not enough to cover the heat losses. So we came an idea to implement heat pump system and design a new system. As a result, we expect to get energy savings, money savings, and others. Before calculation, we proceed to thermal transmittance U values of the structural elements of the building. As you see, we have two equations, one for non-transparent surfaces and other for the transparent surfaces. Only one exterior wall is below the proper limit, it satisfies, other not. Heat calculation. Heat calculation was managed according to a standard. Total heat loss are sum of transmission heat loss, ventilation, and heat loss from break in heating. External temperature was for Belgrade -12 degrees. Inside you see red color. This is our heating area. Blue is non-heated rooms as storages and entrances, and mechanical room. Non-heated 12 degrees, room temperature is 20. Our total heat loss is 36 kilowatts. After calculating the heat losses, we implement our heat units, radiators box, global box for the rooms, and the towel warmer for the bathrooms. As a regulation, local regulation, we use thermostatic heads for temperature, and for per setting our piping system and units, we use Emi-Heimeyer's lock shields, Regulux. Calculation of piping system. We have two methods, one with speed of the flow, other the frictional pressure drop. We defined our diameters, and our total pressure drop on the furthest heat unit is about 9 kilopascals. Cam-termed plastic pipes, and we lead them under the ceiling of the ground floor, parallel, one above another. As you see, This is the isometric view of our system, heating units, and 2 heat pumps. For a heat pump system, we choose 2 parallel connected heat pumps, Fissmann, 16 kilowatts one. This is for 232 kilowatts because our heat loss is much 4 kilowatts more. We use in extreme conditions our electric heaters in heat pumps. For heating of water installation and heating domestic water, we use boilers, Fissmanns. Also, as a safe, we use expansion vessel. Then we step up on the calculation for energy efficiency. This is annual heat losses calculation, method of heating degree days, as you see. Then annual heat gains calculation, interval for people and electric units, and solar gains. A red one is people and electric units, and solar is a blue one. After that, we get energy we need for heating our building. If we use that energy per square meter, we can define our energy class. Energy class of this building is class E, and as measures we can improve our energy class is implement thermal insulation of structural elements as floors, ground floor, and interior walls. And 2 last measures will not improve this energy class, only system and energy savings. So we implement, as we talk about, substitute electric heaters with heat pump system, and implementation of renewable energy sources, solar collectors for heating domestic water. On the left side you see the data and values for electric heaters, and the right side you see data and values for heat pump. As delivered energy for heating is quite same for the both of systems, but a huge difference we see on primary energy. Primary energy for electric heaters is 3 times bigger, so we make savings with implementation our heat pumps. When we speak of emission of CO2, also 3 times bigger is for emission for electric heaters than heat pumps. You see that on the diagrams, left for the energy and right for the CO2 emission. Red is for electric heaters and blue one is for the heat pumps. We not save only energy, but only in costs, because this is the one of the tasks which occupants don't have bills to pay. So with the implementation of heat pump, we save 74% per year of our money. Payback period or payback for our investment is 6 years, which is good number. And as a result and conclusion from implementation of heat pumps instead of electric heaters, we fulfill some characteristics. Thermal comfort, we satisfy thermal comfort, energy savings, 3 times smaller, reduction of CO2 emission, money savings, and we have, with the implementation of heat pump, local and central regulation. Thank you for your attention.
Thank you, Vladimir.